Hello everybody, welcome back to another new video. In this video we will have a question related to the plastic end capacity, and this question, such type of question is repeatedly asking in our final examination. So let's start the solution. So in this figure we have a given frame, you can see here. Okay, in this frame two different external load are applied over here. You can see first one is this 80 kN load is acting on this BC span, okay, and another external load that is 60 kN is acting from this point B, okay, and here is two different load. So due to this 80 kN, this B and C, you can see whenever load is coming from here, then this will be our beam mechanism, okay, and due to this is horizontal force is applied. So due to this, you can see here the show mechanism is occur. So in overall we need to calculate two different mechanism. First one, due to this 80 kN node, will be beam mechanism, and due to this 60 kN it will be sway mechanism. So let's see. And in this case question we have a given load factor is 1.5, you can see here. Okay, load factor is given 1.5, okay, and we need to calculate the plastic moment capacity. So now let's start the solution. Okay, so in very first, as I said, due to this 120 kN load, you can see here, due to 120 kN load, here is a beam mechanism occur in this BC. Okay, so this uh, this BC span will have certain deflection. You can see here delta is delta, and this point comes here after applying the load. So this will be like this, okay, and here is delta deflection, and if this will be theta 1, then this is also theta 2, theta 1, these two will be equal, okay, and now this will be theta 2. You can see here this angle will be theta 2, then this angle also will be theta 2. So this is 2, don't be confused, this is theta 2, okay, and now you can see here this is the right angle triangle, and this one is also right angle triangle. So in right angle triangle, this right angle triangle, you can see here, if you calculate the value of theta 1 is nearly equal to this tan theta 1, okay, and tan theta equals to p by b. It means the value of p is delta, okay, and p by b means 3. So the delta, in terms of delta, it will be 3 times theta 1, okay. So this will be delta equal to 3 times theta 1. Similarly, if we take right angle triangle, this, okay, if you take right angle triangle, this one, this right angle triangle, you can see, then in this figure, this theta 2 can be similarly calculated. Now we are going to take this triangle, okay, this one, okay, this one triangle. So for this is theta 2, and theta 2 will be nearly equal to tan theta 2, and tan theta equal to p by b. So p means delta by b means this one 5. So from here delta can be written as 5 times theta 2. So this will be also equal delta equal to 5 times theta 2. So if you combine these two, then from here you can see here this theta 2, this theta 2 can be written as 0.6 times theta 1. So this is the relation between theta 1 and theta 2. Now let's move uh, for the internal and external work. So you can see here in this figure, we need to calculate two different work, okay. So for the internal one, this will be also MP. This is also 1.5 MP and this is 2 MP. Okay. So in the figure you can see here, the value is given. This is 2 MP, this is 1.5 MP and this is MP. Okay. So from this 2 and we have 1 MP, we need to take less MP value. So this one is 1 MP, so we have to take 1 MP. Okay. And for this C, you can see here we have two different. First one is 2 MP, two different sides, and another one is 1.5 MP. So the lesser will be 1.5. So we have to take this 1.5. Okay. And for this middle span BC, this is 2 MP. So this will be 2 MP. Okay. So in this way we have to take the value of MP, and always remember whenever two sides and two different MP value is given, then you have to always take a smaller one. Okay, keep in mind. Now the value of internal work can be calculated as MP into theta 1. As I seen here, this one you can say. Okay, for this section, this will be MP into theta 1 because this angle is theta 1, you can see here, and this is theta 2. So this for this theta 2, this will be 1.5 MP into theta 2. So 1.5 into, you can see here, this one and this one we have calculated. Now for this point A, we have two different angles, that is theta 1 and theta 2. So total overall angle will be theta 1 plus theta 2 times 2 MP. So this is here, you can see this middle one. So here internal work we have calculated. Now for the internal work, you can see here we have only one load, that is 120 kilometer. So for the internal work, 120 into, and for the external work, you can see here we have uh, calculated the value of external is like this. Okay. And internal work, we have to just multiply the deflection by the external force. So you can see here our external force is 120. So 120 into this deflection. So we have value of delta equal to 3 times of theta 1. So in the place of delta, this delta, we have to just write 3 theta 1. So this value becomes 361 theta 1. Okay. So after calculating this internal and external, we have to equate both, internal equal to external. So now we have internal work done equal to external work done, you can see here. Then the value of MB we will get 70.55 kN/m. Okay. So this is for the beam mechanism. Now we have a sway mechanism. Okay. So for the sway mechanism, you can see we have a sway mechanism occurs due to this horizontal load. Okay. So due to this horizontal load, sway mechanism occur. So here two different deflection will occur, that is here delta and this will be delta. Okay. And the angle made by this is theta 1, this is also theta 1. Similarly for this point C, we have two different angle, that is theta 1 and this will be theta 1. Okay. And similarly the value of MP can be taken for this MP, this is for 1.5. Okay. And this for A is MP and this is for 1.5 MP. So as I already said, whenever there is two member, then we have to take a lesser value of MP. Okay. So now you can see here we have two different work done, that is internal work done and external work done. So if you talk about the external work done, so we have to just multiply this delta by the theta, delta by a load applied over here. You can see here, here is load is applied 90 kilometer. Okay. So 90 into delta. So you can see here external work done equal to 90 into delta, only that much. And the value of delta in terms of theta A, theta 1 can be calculated. In this case here you can see theta equals to p by b. So it means delta upon this total height is 5. Okay, so the value of delta can be written as 5 theta 1. Okay, so in the place of delta we just put the value 5 theta 1 and external work done will get 450 theta 1. Okay, so this is equation number 1. And for the internal work, you can see here, for this point you can see this will be mp into theta. Okay, just this one. Okay, and for this point you can see this will be 1.5 mp into theta 1. So 1.5 mp into theta 1. And for this point you can see this will be 1.5 mp into theta 1. So this is 1.5 mp into theta 1. And for this point this will be mp into theta only. So this value is here, mp into theta 1. So after calculating this value we get 5.5 mp theta 1. Okay, it's written here, this value 5.5 mp theta 1. So we have to equate these two value, that is internal work on this one and external work on this one. So after equating these two value we get the value of mp equal to 88.81 kN. So you can see here we have two different value of mp. Okay, for this sway mechanism we have the value of mp is 88.81, right? And for this beam mechanism we have different value, that is 70.58. Okay, you can see here we have two different value. This value will be 70.5. Okay, and this will be 88 point. And similarly for the combined mechanism we have a, if we take the right angle triangle this one, okay, then in this case theta will be equals to this value is 4. Okay, so the value of tan theta equals nearly equal to tan theta, and this value will be delta by 4. Okay, so from here delta will be equals to 4 times theta. Okay, so you can see here delta will be 4 times theta. Okay, and similarly for the another triangle, this right angle triangle and this right angle triangle, we get the value of delta equal to 5 times this theta. Okay, so after solving these two value we get the value of theta 2 equal to 0.8 theta and theta 1 equal to 0.6 theta. Okay, now we need to calculate the value of uh, external work done and internal work done. Then we have to equal these two value. Okay, so for first external let us calculate the external work done. So if we calculate the external we have two different external load. So first one is due to this in the middle part, that is 90. So 90 into this value will be 120, acting from upward to downward. So 120 into this delta 1. So this value will be 120 into delta 1, and another one is acting 90 kN horizontally. So this due to this deflection delta, so delta into 90, because this load into deflection we have to do. Okay, just multiply deflection by the load. So 90 into delta. So in overall our external work will be this much. Okay, and if we talk about the internal work, then this value will be mp into this theta. So this value, and another one 1.5 mp into this theta 2. So this will be, and for here this will be theta plus theta 1. Okay, so theta plus theta 1 into 1.5. Okay, and here this will be theta 1 plus theta 2 into 1.5 mp, this value. Okay, and for this theta 1 plus theta will be 2 mp this, and after calculating we get 7.5 mp theta 1. Okay, and we need to just do equal this value, that is internal work done and external work done, these two value. Then finally the value of mp we will get 96. Okay, and from this we have a three different mechanism. First one is combined, third one is combined mechanism. In combined mechanism we can see we have calculated the value 96. Okay, similarly for the first way mechanism we have calculated 88 point, this one 88.81. Okay, and here for the b mechanism is 70. So in our all these three value we have a maximum value of amp is 96. So in the final plastic movement capacity we have to take the larger value, that is the highest value. So in this case we get the highest value is 96 kilonewton meter, which is our required plastic movement capacity. Okay, so this much. Thank you very much. Thanks for watching.